In this video, we're going to discuss something that's a little confusing to many network engineers, myself included from time to time, and that is how to determine subnet masks. Now first, a little bit of review. You'll recall that IP networks fall into a few general high-level classes. Those are those class A, B, and C networks that we discussed earlier in this course and in the ICND1 course. Now, in order to efficiently use these networks, it is important to be able to split these networks into smaller chunks so we don't waste address space. Now, this ability to split networks up is not really a huge deal in the RFC 1918 private IP address space, since most networks have IP addresses to spare. I mean, come on, you've got an entire Class A network that's got something upwards of 16 million IP addresses in it. Certainly you can find something in there. Where this does come into play is with public IP networks. When you run a business and you're given a public IP address space, your provider may say, here is a quarter of a Class C network, or here is half of a Class C network. They'll give you an IP address and a subnet mask and leave it up to you to figure out what the usable address range is sometimes. As a result, that's why you have to know how to do this, not just for the exam, but also you need to understand the basics of how this works, so that as you're using these subnet tools that I'm going to talk about at the very end of this slide deck, you know how those tools got the answers that they got. Now, you'll recall we mentioned this in the ICND1 exam. We get a lot more in-depth with this here in the ICND2 exam, and if you proceed forward into the CCNP routing and switching, you'll really touch on this heavily in the CCNP route exam. So as with many things in the networking world, I'm just going to show you how to figure this up using a couple of examples. Now here's the first example. What is the last valid host on the subnetwork 192.168.65.71 with a subnet mask of 255.255.255.240? Now the first thing you'll need to memorize, if you will, is this binary number chart. To those of you that have some experience with mathematics, this won't be a big deal. To those of you like myself who barely made it through advanced calculus in high school, this might prove to be a little taxing after all these years. But you have to know at the very base how to convert a number from decimal to binary. So let's take this IP address that we have here, 192.168.65.71. The way we do this conversion is we start at the very left of the binary number chart, and we put a 1 in every column that would add up to 192. So the easiest way to do this, at least in my opinion, is just to start at 128. Well, is the number we're looking for above 128? It is above 128, so this highest bit will be turned on, this 128 bit. So we add 128 plus 64. In this case, 128 plus 64 happens to be 192. So we know that since we've arrived at our answer already, all the rest of these bits are zeros, so the correct answer is 110000000. So let's look at 168. Well, again, the number is above 128, so we leave that bit on. 128 plus 64 we already know is 192, so that's too high, so this bit is a 0. 128 plus 32 is 160, so we're getting close. We know that this is 160. We just need 8 more bits. In this case, it's going to be this fifth bit here, the number 8. So in this case, the answer will be 101010000. The next number is 65. That's obviously 64 plus 1. So the correct answer is 01000001. And then 71 is simply 64 plus 7. So in this case, it's 01000111. Let's see if we're correct, because I figured this up using calculator, and let's see how close I got. Hey, I was exactly right. Funny how that works. So now we have our IP address in binary. I'm not going to go through reading all of that again because I don't want to put you to sleep. The next thing we do is convert the subnet mask to binary. Now this is a lot easier because the first 3 octets are all 255s, and we know that 255 is 8 bits, so it's 3 octets of all ones, followed by 1 octet of 4 bits on, and we got that just by 128 plus 64 plus 32 plus 16 equals 240. The next step we do is to binary AND the network address, or the IP address in this case, and the subnet mask. And when you binary AND 2 numbers together, you write the numbers one over the other. If both bits are a 1, then you get a 1 in the output. If either of the bits are a 0, you get a 0 in the output. In this case, this gives you the network address. If you add up all of these bits, it comes to 192 192.168.65.64. So that's the network address. You convert the host portion, the last 4 bits here that you got from the subnet mask, to all ones to get the all ones address or the broadcast address. In this case, it gives you 192.168.65.79. And in our case, the last usable host is 1 less than the broadcast. So the answer to this example is 192.168.65.78. That is the last valid host on this network with that subnet mask. I'll pause here, and in the next video I'll show you what I consider to be a simpler way of performing this same function.